Hello, in this lesson we will be solving a quadratic word problem. So let's go ahead and highlight what we have here in this word problem. And it tells us that the length of a rectangle is 7 more than twice its width. And it goes on to tell us that if the area of the rectangle is 60 square units, what is the width? Now let's go ahead and draw a rectangle to see what is happening. So we draw the rectangle and we're given that the length is 7 more than twice its width, which means that the length is 2w plus 7. The width is w, since that's what we're looking for. The area is 60 square units. Now we can use the formula for a rectangle, which is area equals length times the width, and I will write that right below the word problem. Area equals length times the width. Let's fill in our values from the rectangle. We see that area is 60. That is equal to the length, which is 2w plus 7, times the width, which is w. Okay, so now what we're going to do here is distribute and multiply. 2w being distributed, 2w is 2w squared. And then 7 being distributed to w is equal to 7w. So that's plus 7w. And of course, we have our 60 on the left. Now, what we have to do here is move everything to one side. So that way it is equal to 0. And we can subtract 60 from both sides. On the left, we can see that it is equal to 0 because 60 minus 60 is 0 equals 2w squared plus 7w minus 60. And I'm just going to rewrite this to where it is equal to 0. So 2w squared plus 7w minus 60 equals 0. Okay, so the next thing we have to do here with the quadratic is to identify our a, b, and c values. And we can see that a is 2, b is 7, and c is negative 60. So we're going to multiply a and c to start the AC method. We can see that 2 times negative 60 equals negative 120. I'm going to bring the negative 120 up here to the top. Now, the next thing we have to do is to find two numbers that multiply to give us negative 120 and add to give us positive 7. So the two numbers I'm thinking of is 15 and negative 8. And the reason why is because 15 minus 8 is positive 7, and 15 times negative 8 is negative 120. So what this means is that we're going to rewrite the middle term using 15 and negative 8. So rewrite the quadratic as 2w squared plus 15w minus 8w minus 60 equals 0. Okay, so the next thing to do is to group the first two and the last two terms. So let's go ahead and do that. So there we go. And what we're going to do is factor out what's common from each group. So starting with 2w squared plus 15w, what's common is w. So we'll factor out a w times 2w, because w times 2w is 2w squared plus 15, because 15 times w is 15w. Bring down your minus, and what is common to 8w minus 60? It is 4. So we'll factor out a 4 times 2w. Okay, because negative 4 times 2w is negative 8w. And then negative 4 times what equals negative 60? Well, that is positive 15. That equals 0. Okay, so now what we're going to do is factor the 2w plus 15 out. So we have 2w plus 15 times w minus 4 equals 0. Now we're going to set each factor equal to 0. Let's do that. So we have 2w plus 15 equals 0. Subtract 15 from both sides. And we see that 2w equals negative 15. Divide by 2 on both sides to solve for w. And w equals negative 7.5. So what we're going to do is reject the negative because you know that the width can never be negative. Now let's set w minus 4 equal to 0. W minus 4 equals 0. Add 4 to both sides to solve for w. And we see that w equals 4. That is our width. Our width is 4. And if you want to check what your length is, all you have to do is substitute that w for the 4. So we have 2. Let me change the color really quickly here. So we have 2 times 4 plus 7. And 2 times 4 is 8, plus 7 is equal to 15. Meaning that the length is 15. And that is true because when you multiply the length times the width, 15 times 4, that gives you the area of 60. And that's how you solve a quadratic word problem step by step using the AC method. In the next problem, we'll see how a quadratic can help us find the maximum area of a fenced region. So keep practicing and stay tuned for more calm, clear algebra lessons right here on Math by TV.